Okay, my friends, nice to see you again. We are back with a brand new chapter, chapter 9. Today's homework is 9.1, the areas of triangles and quadrilaterals. So, as you can see, we've got our definitions here, and it's learning our different formulas for our different shapes. So that's going to be really key to this particular chapter. So we'll go over the definitions and the particular areas. And then I have 3 questions, practice problems for the homework. And then there'll be another video following up going over some of the classwork problems. But let's go ahead and get started. So let me just say again, I miss you all. Well done on Chapter 8. Proud of you guys. Keep it up. We're getting near the end. This is pretty much likely our last chapter of the school year. Hallelujah. Praise God. Okay, so first thing, parallelogram. Quadrilateral with 2 sets of congruent sides, if you remember from a couple chapters ago. Very simple area formula. It is simply the base, or the length, times the height. So for a parallelogram, you just need to know how long it is on one side. Area equals the base times the height. So it's just like a rectangle. You want to make sure, of course, we're not talking about the slanted sides. You'll always have a perpendicular height from whatever you call the base. And I could turn it this way and call this the base, but then I would need a perpendicular height going that way. So just remember, it's not the sides times each other. It always has to be the base and then the height. Okay, then our triangle is really, all triangles are just half of a rectangle or half of a parallelogram. So it's going to be very similar. We're going to have our height and our base. And it's going to be area equals 1/2 base times height. And there's a lot of cool videos out there where they demonstrate and show you just that. Again, this is really just half of this shape, and I could sketch out the other half of the parallelogram, be like something like that. And so it's the same as this, but just half of it. So 1/2 BH. Then we have trapezoid. Trapezoid, ignore this line. I made a little mistake as I was prepping. But you have now a 4-sided quadrilateral, but you only have one set of parallel sides. The other set is not parallel. So that means it's going to give us a slightly different formula, but it's because now we do have our height. Notice the perpendicular line being our height. But now we have base 1 and base 2 because you have 2 different lengths. Here the bases are the same. Here you'll have one that's shorter than the other. And so your formula here for your trapezoid is it's actually going to kind of combine these. It's the area equals 1/2 times base 1 plus base 2 times the height. Okay, so you're going to add the 2 bases together, multiply by the height, and then basically cut it in half. And that's something to say about these halves is you can multiply by a half or 0.5 on your calculator, but it's the same as dividing it by 2. You see in the book, this actually is written as B1 plus B2 times H all over 2 because that's what multiplying by a half does. Okay, then that leaves us with the rhombus and the kite. And what you want to look at for the rhombus and the kite are these red lines here. These are the diagonals. I'm going to write it out. The diagonals are important in each case. They're going from vertex to vertex. And for a rhombus, it's simply the area is area equals 1/2 the first diagonal times the second diagonal. And notice the subscript. That doesn't mean, I did that in both of these cases, that doesn't mean, it's not a square root or anything. It just means the first base, second base, first diagonal, second diagonal. And it doesn't matter which one you call base or which diagonal you call which diagonal. It can be either one. So you just multiply these 2 diagonals times and then divide it by 2. And it's the exact same thing for a kite. The difference between a rhombus and a kite being these are congruent here. However, these are not. Actually, I'm sorry. These are not necessarily congruent. Take that out of whack. No, but these diagonals, and then you have your kite, but it's the exact same formula. Area equals 1/2 diagonal 1 times diagonal 2. Okay? Okay, I think we're ready to launch into it. Oh, the thing I was going to point out is that a rhombus is like a parallelogram. And so you actually have two formulas for a rhombus. They give you the diagonals, 1/2 d1 times d2, that's actually, I think, the easiest. But if for some reason they gave you the outer, an edge of a rhombus and its height, that you could use the exact same formula as a parallelogram. And so you could use area equals base times height for a parallelogram as well. So this one actually has two, depending on whether they're giving you diagonals or they're giving you base and height information. Okay, so task number 1 of this chapter is going to be memorizing those formulas. The second tricky thing is that they're not always just going to give you base height and calculate area, or diagonals and calculate area. And the slight little twist that you're going to have to get used to, and it's not difficult if you just practice it, and that is they're going to oftentimes give you the area and then have to solve back for one of the dimensions of the shapes. So I've given you 3 simple examples of this as your warm-up questions, your homework questions, just to get used to that. And the real key to doing it is writing out, until you get good at it, is writing out the formula so that you can just algebraically solve for whatever's missing. And so I'll show you that with these 3 questions as an example. So number 1 says, find the height of a rectangle whose area is 120 square inches and its length is 60 inches. Okay, so notice again, I kind of gave you the quote-unquote answer by giving you the area, but now you need to go back and calculate the height. And again, as soon as you can intuitively see that, go for it. But I'm going to work real slowly for people who are uncomfortable with the fact that you're kind of working a little bit backwards. So what I would recommend is you write out the formula. Area equals base times height, because we have a rectangle here. And so I know the area. So actually what I would probably do is I would do something like this. Area equals base times height. I know the area is 120 equals 60 times h, because I don't know the height and my base was 60. Now it's just an algebra problem. Opposite of multiplying by 60 times would be to divide by 60. So I'm going to divide both sides by 60, and I can see that my height is 120 divided by 60. You can use a calculator. We don't need it for this. That's just simply 2. So the height of this rectangle is 2 inches. Okay, units are important in area, so I'm going to try to keep track of those. But notice again the process. Write out the formula for the shape you've been given. Plug in the information they gave you. If they gave you the A, put in the A. If they gave you the B, put in the B. Solve then for H. 60 times what is 120? The height must be 2. Okay, let's look at 2 other examples. Number 2 was a triangle whose area equals 24 square inches. 24 square inches, and whose height is 6 inches. So I've given you the height, and then we don't know the base. Sorry, that inches is really small there. So we know the height is 6. We don't know the base. So let's just follow the exact same for process. So area for a triangle is 1/2 base times height. And then let's plug in what we know. The area is 24 equals 1/2. I don't know the base, but I know that my height is 6. So 24 equals 1/2 base times height. Okay? And so now we put these in parentheses, we're multiplying. And now we need to solve backwards. Now there's 2 ways to do that. What I recommend, well, that's up to you. When you have this half, because you're going to deal with it with you have it in 4 of your formulas: triangles, trapezoids, rhombuses, and kites. The 2 things to quickly solve that is, 1, what you can do is you can quickly cut in half one of your numbers here. So I could multiply 1/2 times 6 and simplify this to 3b. My other option is to immediately do the opposite of cutting it in half, and that is double my answer. Because in all of these problems, the last thing you did before you got the area was you cut it in half. And so if I'm working backwards, the first thing I would do is double it. Okay? So it's up to you which way you would like to do that. I'm going to go ahead and use that method because that just might be a good habit to develop, but either way is right. Again, I could cut this in half and say 24 equals 3b, or what I'm going to do is I'm going to go ahead and double my answer and say 48 is equal to now 6b. Okay, and that's how I undid that doubling. I multiplied, I'm kind of running out of room here, but I multiplied both sides by 2, and 2 times a half cancels out, and 2 times 24 is 48, and now I'm left with a problem similar to I had before. Instead of multiplying by 6, I'm now going to divide by 6. That cancels out, and so I am left with b equals 48 divided by 6 is 8. So 8 inches is my base of my triangle. And you can always go back and check your work if you want to, practice it again. Plug it back into the formula. 6 times 8 is 48, divided by 2 is 24. Yep, that's right. Okay, and then the last problem. Sorry, I'm getting information off my computer. It keeps going to sleep. Here we go. Last one is the diagonal of a kite. When I know that the area is 50 square inches, kept it consistent, just keep it simple, and that one of the other diagonals is 25. Okay, so I know this is 25 inches. I need to find my other diagonal. It's kind of crooked. If the area is 50. All right, so let's start out. We write our formula. Area equals, for a kite, 1/2 d1 times d2. I know my area is 50 equals 1/2 times 25 times the diagonal that I don't know yet. Okay, we're just barely squeeze this one in here at the bottom. So notice here, when I talked about your two options here, you can notice the second one's better because cutting 25 in half would give me a decimal. So I'm going to not do it that way. Like I said, the way I'm going to consistently undo my half is by multiplying both sides by 2. So that cancels out, and I get 100. 2 times 50 is 100 equals 25d. So now something times 25 is 100. And you probably don't have to work slowly to figure that out. But if I'm not sure, divide by 25 instead of multiplying. And so 100 divided by 25 is 4. 4 quarters in a dollar. 4 equals the missing diagonal. 4 inches. No naked numbers. How embarrassing. Okay. 4 inches is my other diagonal. Okay. So all three of those basic examples, you'll see some trickier ones that we'll review on the classwork. But the habit this book is going to make you get into is that we're doing area, and it's a lot of just plug and play, but they're going to give you the areas many times, and you're going to have to work backwards to find the missing base or the missing height or the missing diagonal. So that's what we're practicing here in these questions. Okay, please reach out with questions or help that you have, and otherwise for the classwork, if you need help, there'll be another video for you to watch there. All right.